Today we're going to start with a problem of finding an equation for a sinusoidal graph. And we're going to see if these 2 points are enough to find the 5 pieces of information we need to write the equation. So pause the video now to try to find those additional points. And then the amplitude, the middle, the period, and the value b that we'll use as a coefficient of x. Choose a starting point and write an equation. Right now, the people at home are pausing. All right, welcome back. So let's take a look at what we can determine from these points. First thing we'll notice is that the top has a y-coordinate of 15. So whatever that other top point is in the x-coordinate, the y-coordinate is definitely a 15. Use an alternate color here. We also see that the y-coordinate of the middle points is 7, and they all have to be the same. So whatever is going on in these x-coordinates, 7 is the middle. And that happens to be one of the things that we're looking for. What is D, the middle? And it looks like the middle is at 7. Now we can look for the vertical distance from the top to the middle. At the top, we have a 15. In the middle, we have a 7. That's a total of 8 units. And now we know the amplitude. So if we just take the 15 minus 7, that gives us an 8. Now the amplitude is the same from the middle to the top and from the middle to the bottom. So if we take the middle 7 and subtract the amplitude, that'll tell us where the bottom is. So now we know all of our vertical information. The bottom is at -1, the middle is at 7, and the top is at 15. 7 plus 8 is 15, 7 minus 8 is -1. So it's D plus or minus 10. Now we need to work out some horizontal information. The period is going to be the distance between any 2 points with the same name. So from a middle going up to another middle going up. From a top to a top, from a bottom to a bottom, from the middle going down to another middle going down. But what we have is we've got a -2 at this top point, then we're missing 2 points, and then we have a 13 at the middle going up. So when we've taken 1, 2, 3 steps, and that's 13 minus a -2. So what we want to notice is that 3 steps and if we think of steps as quarter periods, is 13 minus a -2. So 3 quarter periods is 15. So that means 1 step for a 1 quarter period is 5. So now we know how big the horizontal steps are between each of the named points. Top to the middle going down, that's going to be 5. So -2 plus 5 is going to put us at 3. 3 plus 5 will put us at 8. 8 plus 5 is 13, so this seems to be working. 13 plus 5 is 18. And if I go backwards, -2 minus 5 is -7. So if a quarter of the period is 5, that means one full period is 20. So if a quarter of a period is 5, that means one period is 5 times 4, or 20. We could also calculate the period by looking at the difference between any two similarly named points. So 13 minus a -7 is also 20. Then the last thing we need to do, as far as this, before we choose a starting point, is to figure out what is going to be the coefficient of x in our equation. Since the period is 2 pi divided by b, b is 2 pi divided by the period. So b is 2 pi divided by the period. So it'll be pi over 10. So I've got an amplitude of 8. The middle is 7. The coefficient of x is going to be pi over 10 because the period is 20. Now all we have to do is choose a starting point and write an equation. My favorite starting points are the ones that are closest to the y-axis. So that -2, 15, and 3, 7 would be my first choices. But if for some reason we really wanted to do positive sign, we could go with -7, 7. If we really wanted to do negative cosine, we could go with 8, -1. So if we start at -2, 15, this is at the top. So we're going to use a plus cosine. And c is -2. So our equation will be y equals. We're doing a positive cosine, leave a space for a. A is our amplitude, 8. Our coefficient of x, after the cosine, the coefficient of x is pi over 10. We have x minus a -2, so that'll read as x plus 2. Close the inner parentheses, close the cosine, plus the vertical shift. So here's an equation, the graph shown above. This would be my first choice. Since -2, 15 is the closest named point to the vertical axis. My second choice would be 3, 7. That's a negative cosine, but it's also the second closest to the axis. So if I think of 3, 7, we notice that this is at the middle and headed down. So we're going to use negative sign. So we write our equation, y equals. We write negative, leave a space for a, sign, and open some parentheses. A is 8. After the trig function is the coefficient of x. In parentheses, we have x minus, and in this case, c is equal to 3. So it just shows up as x minus 3. close the inner parentheses, close the trig function, plus the vertical shift. So there's another option. Questions? The next closest point to the origin, let's suppose that we really wanted to use positive sine. For some reason, it has to be listed with a positive amplitude, and well, the amplitude is always positive, but it has to be a positive coefficient of the trig function, and we have to use sine. So our two candidates are -7,7 and 13,7. Those are both positive sine locations. -7,7 is closest to the y-axis, so I'm going to use that one. So if we choose -7,7, that is going to be a positive sine. So it's the middle going up. So that means we have positive sine, and C is -7. Part that's changing is the horizontal shift and whether you're using plus or minus sine and cosine. Think back to our sines and cosines and how we define those functions. And one of the early discoveries that we made was that the sine and cosine of complementary angles will be equal. Sine of 30 is equal to the cosine of 60. We're maintaining the same shape, just shifting it left and right. Questions? I've only done 3 out of the 4, and it's starting to drive me crazy. If I stopped at 2, everything would have been fine, but the last one we have is at the bottom, 8, -1. So at the point 8, -1, we are at the bottom, which means we're going to use negative cosine. And C is equal to 8. So our equation, I'll do it printing press style. Any questions? How's everybody okay? So this shows us that we can take a collection of points. If we get some idea, 2 points that are at different locations vertically, as well as 2 points that are at different locations horizontally, then we'll be able to figure out all of our vertical information and all of our horizontal information. Once we can fill out any number of points, we can write an equation that fits that description. All I need to do is give you two different points that have a different vertical location and a different horizontal location. If I give you the top and the middle, that gives you the amplitude, and then you just apply that to the bottom. If I give you the top and the bottom, that gives you double the amplitude. You cut it in half to figure out the middle. Everybody okay? Here's the next part of the task. What I want you to do is go out and find a sinusoidal function in the wild. I want you to find some kind of information, some kind of function that has a period to it and an amplitude, something that will go up and down and up and down. Go out and find a sinusoidal function out in the wild. And identify all the things that we need to know to write an equation. The amplitude, the middle, and the period. Use that to fill in a bunch of points. Then choose a starting point. And write an equation. And remember, from the starting point, you're going to get the plus or minus, sine or cosine, and also the horizontal shift. So think about where we might find sinusoidal functions out in the wild. Find some information about that, find some data, and see if you can make a sinusoidal equation that fits that data. Any questions? Comments? Any thoughts? It's a good question to have before a 4-day weekend. It gives you more time to find one of these sinusoidal functions out in the wild. But then I realized this is a Tuesday, Thursday class. They are all 4-day weekends. So at least 4-day math weekends. So if you're worried that you don't actually have 4-day weekend being different in this class, don't worry, I would have done this anyway. I was really just taking the opportunity to point out that there's a 4-day weekend and you don't have your other class. You might be thinking, dude, I programmed this so that I would have 4-day math weekends all the time. What if we just had 4-day weekends all the time? That's pretty dope. Anyhow. Maybe the reason that not everybody is employed is that there's less work that actually needs to get done than we think there is. You know what I mean? All right, let's take a break and then we'll come back and talk a little bit more about radians and trigonometric functions. All right, let's pause for a minute. Well, 5 minutes.